This agent replaces a junior researcher. But it's not magic, it's a carefully designed, multi-layered software architecture. Most people treat LLMs like a fancy autocomplete. They input a prompt, get an answer. But when the task requires action, like browsing the web or performing multiple sequential tasks, that simple loop breaks. To achieve true autonomy, you need to transition from a single-shot prompt into an execution loop. Think of it as building a micro-OS for your AI. The core of our ghostworker is the orchestrator. It's not just calling GPT, it's managing the state, deciding if it needs to browse, and then integrating the observation back into the prompt. Let's look at the brains, the task planner. Its job is to decompose a massive goal, say, analyze competitor XSQ3 strategy, into tiny, executable subtasks. This is where the initial prompt engineering pays off. We don't just ask research, we instruct it to generate a sequence of actions: search $, itaro $click $, itaro $extract $, itaro $summarize. Now for the execution. The action executor takes that instruction and translates it into a specific API call to our integrated browser module. The browsing module isn't just typing into Google. It simulates a real user, handling CAPTCHAs, dynamic JS loading, and gracefully managing timeouts. Observation is the feedback loop. The browser returns raw HTML text. This observation must be passed back to the orchestrator, not directly to the next prompt. The orchestrator then packages that raw observation into a highly specific prompt, saying, "You searched for X. The result is Y." What is the next logical step? This constant cycle of action $, itaro $observation $, itaro $thought is the heart of autonomy. It allows the agent to self-correct and pursue a goal, rather than just executing one linear instruction. And that leads us to memory. Without memory, the agent is stateless and forgets its goal after one search result. We implemented both short-term context buffers and long-term vector memory. Short-term memory holds the immediate context of the current task, the last 5 search results, the current page content. It keeps the conversation grounded. Long-term memory is crucial for scaling. It's a vector database that stores successful intermediate findings, allowing the agent to reference previous research runs without having to regenerate them. When the task planner needs to adjust strategy based on past attempts, it queries this vector DB. This is how the agent learns and improves its approach. The final phase is synthesis. Once all subtasks are complete, all data collected, all pages scraped, the orchestrator signals the synthesis engine. The synthesis engine takes the mountain of raw observations and performs high-level abstraction, finding correlations, identifying biases, and structuring a cohesive narrative. This is where we move from data collection to intelligence. The agent doesn't just summarize, it draws conclusions and posits hypotheses. The output is not a blog post. It's an actionable executive brief, tailored to the initial goal and ready for human consumption. But what if the web page is behind a paywall or requires login? The agent must handle failure gracefully. This introduces the concept of retry loops. We coded a robust error handler that monitors API limits, HTTP status codes, and timeouts. Instead of crashing, the agent tries alternate search terms or suggests a different access point. This resilience is what separates a clever script from a truly autonomous agent. It's the difference between throwing spaghetti at the wall and having a robust, self-healing system. To summarize the architecture, the orchestrator is the conductor. It balances the LLM's cognitive power with the brute force of the execution modules. The agent is the body. It executes instructions, clicking, typing, scraping. The LLM is the brain. It provides the high-level reasoning, decomposition, and synthesis abilities. Building this ghostworker isn't about finding one magic API call. It's about engineering the middleware that allows intelligence to act in the real world. If you want to go from concept to execution, stop trying to cram everything into one prompt. Start by building the action layer. The next step? Start simple. Build the planner and executor pairing first. Then, layer in memory and error handling. The full code base and detailed guides are linked in the description below. Go build your Ghostworker.